This is CCEA A2 Pure Maths. We're looking at some integration past paper questions, and this is one then from June 2016, question 7. It says the figure below shows a sketch of the curve y equals 1 plus sine 2x. So this is it here. The curved surface area of a bottle stopper can be modelled by rotating the curve 1 plus sine 2x between 0 and 3 pi over 4 through 2 pi radians about the x-axis. Find the exact volume of the bottle stopper. So we want to set up then our volume formula. So we know it's volume equals pi integral, and we're going between 3 pi over 4 and 0, and then it's going to be our y squared, so it's 1 plus sine 2x whole squared dx. So we need to multiply this out, and we're going to use FOIL then to multiply it out. So volume is pi 3 pi over 4 and 0. We're going to get 1 plus 2 sine 2x plus sine squared 2x dx. This here we can integrate, this we can integrate. Powers of trig functions tend to be a wee bit messy to integrate, so we're going to need to use the cos double angle formula then and rearrange this. So our cos double angle formula, if I do it over here, I'm trying to write it quite small so we can see. Our cos 2x we know equals 1 minus 2 sine squared x, and we want to get the sine squared x on its own. We'll worry about the 2x in just a wee second. So I'm going to take this over to this side and this over to this side. I hope you can see this move okay. So that means sine squared x is equal to a half minus a half cos 2x, and it means sine squared 2x is actually going to equal a half take away a half cos 4x. If I'm changing this to a 2x, the same would change to a 4x. So I can change my sine squared 2x to a half minus a half cos 4x. And what that does is means it's more straightforward than to try and integrate. This is an easier thing to integrate than this. That's the idea behind it. So I rewrite my integration line, then we can go ahead and integrate. 3 pi over 4 and 0, 1 plus 2 sine 2x plus a half minus a half cos 4x dx. So we're now in a stage where we can integrate. So let's go on ahead and keep the pi outside the front. Integrate to 1. Alright, well, do you know what I'm going to do? I'm going to do the 1 plus a half, so that's 1 and a half. So that is going to give me then 3x over 2. I hope you're okay with that, because that's just a number there and that's just a number there. So we'll add them together before we integrate, and we end up then with that. Integrating 2 sine 2x. If I integrate sine 2x, I would get minus a half cos 2x. So if I'm integrating 2 sine 2x, it's going to be minus cos 2x. And then we have this, if we integrate cos 4x, we would get a quarter sine 4x. So this is going to be minus an eighth sine 4x, and that's in between 3 pi over 4 and 0. So we need to do a wee bit of working out here. So pi upon, I'll just give me a second, 3 pi over 4 substituted in here. We multiply the 3 pi by the 3, that gives me 9 pi, and then over 8. Cos of 2 upon 3 pi over 4, so that's 6 pi over 4, and that's cos then of 3 pi over 2, which is the same then as 6 pi over 4, and that gives us 0. Sine of 4 times that, so that's going to be sine of 3 pi. Sine of 3 pi is just 0 as well. Think about the graph of sine. Take away substituting 0 in here. 0, that's just going to be 0. Remember, cos of 0 isn't 0, so cos of 0 is 1. So that's then going to be minus 1. And then that's going to be a 0 as well. So that's what we end up with. So our final answer, if you wish, then would be 9 pi over 8 minus 1. So that's plus 1. And that's our answer there.